Today we're going to look at an introduction to polynomials. We're going to start with some of our vocabulary. The first thing that we need to know is what is a term. A term is one part of an algebraic expression, so part of something bigger, which might be a number, a variable, or a product of both. Let's look at some examples. If the term was simply a number, it could be 7, it could be -5, it could be 2,415. Or our term could just be a variable. It could be an X, a Y, a Z. It could be any alphabet letter. Or finally, it can be a product of both. We can have a number and or a variable. 7x or -5y. Now let's look at some more specifics for polynomials. The first is when we have a monomial. Mono, meaning one, would be an expression with just one term. -5y is a monomial. +5xy squared z is a monomial. They each have one chunk of information. Let's compare that to a binomial. This is an expression that actually has two different terms. The first term, 5y squared, is separated by a subtraction sign, -3y. So our first term is considered the 5y squared. The second term is a -3y. So binomial has two terms. Trinomial has three terms. Building on that first one, 5y squared is our first term. -3y is our second term. And +1 is our third term. We can move beyond that, and we simply refer to it as a polynomial. It's the sum of all the terms in a variable expression, and it also refers to expressions that have more than 3 terms. So it's a very generic word. Instead of saying grade 9 student, we might just say students. So in this particular polynomial, we have 1, 2, 3, 4, 5 individual terms. You're going to be asked to calculate the degree of a polynomial, and you'll need to follow a certain set of rules. For each variable, you need to identify all of the exponents. You need to add all of those exponents together. The sum of the exponents is referred to as the degree of the term. If you happen to have a polynomial with more than one term, the highest term is the degree for the whole polynomial. Let's look at some examples. Here we have a monomial, 4z squared. We're going to list the exponent values. The exponent for z is 2. It's the only number we have, so the degree is 2. 5ab squared. The b has an exponent of 2, but the a also has an exponent. It has that 1 that we don't need to write down, but we need to be aware of. So the exponent values that we have are 1 and 2. The sum of those is 3. So the degree of the entire term is 3. Let's look at another one. When we're considering 15, 15 does not have a variable. Therefore, if it doesn't have a variable, there's no exponent on the variable, and the degree would simply be considered 0. Here's a longer one. Y has an exponent of 2. Jot that down. Our f doesn't appear to have an exponent, but we know that there's a 1. We need to consider that. Our t has an exponent of 3. And our z has an exponent of 5. When we add those all up, we have a grand total of 11. The degree of this entire term is referred to as 11. What happens when we get into polynomials where we have more than one variable? We're going to start the process the same. We look at the z. It has a degree of 1. But once we switch to a new term, we then begin deciding which term has the higher potential. This z has a degree of 2. Then we ask ourselves, which is bigger, 1 or 2? That means 2 will become the default degree for the entire polynomial. Let's look at another one. In the example, 5y squared minus 16y to the 5 plus 3. Our first term has an exponent value of 2. Or we can look at our second term, which is negative 16y to the power of 5. We're considering 5. And our last term is 3, but there aren't any variables, so it's a 0. And we look for the winner, which is higher, 2, 5, or 0, and the answer is 5. Here's a really long one. The process is exactly the same. I'm considering the 6, no variable there. I'm considering the 2. I'm considering the 8, no variable there. I'm not even going to begin to show my work on this one. I'm going to be super lazy. I'm looking at it with my eyes, and I can see that the winning term, or the largest term, is number 8. Here's another one. No term, no degree, 2, or 3, or 5. So I could list them, or I could simply scan and see that 5 is the highest of the terms. Therefore, the degree for the entire polynomial is 5. A couple more that are trickier. Y to the power of 3, z would be to the power of 1. Altogether, that particular term has a degree of 4, the 3 and the 1. The next term, 3z squared, only has the one exponent, which is a 2. So we're asking ourselves, is it the 4 or is it the 2? And the degree is the 4. One more. Here's our first term. We have x squared, y to the power of 1, z to the power of 5. Altogether, we have a grand total of 8 for that particular term. For our next term, negative 16y z cubed, the y has a 1, the z has 3. Altogether, that particular term has a degree of 4. 3z to the power of 2 only has one variable and one exponent for 2, and 7 does not have a variable, so it does not have a term to consider. Then we ask ourselves, which is bigger, the 8 or the 4 or the 2? And by now, I'm hoping it's becoming a little obvious that the 8 is the biggest. So in your homework today, you're going to be asked to do a number of things. The first is you're going to be asked to figure out the degree of a particular polynomial. You'll be asked to find the variables, the coefficients, and the constants. So let's start with the degree. We know that the k has got a 1. We know that the 3k has a 2. This one does not have any degree. The degree here is a positive 1. The degree here is a 2. So the degree for all of them is a 2. The next thing that we're going to look for is our variables. So the variables are the alphabet letters, or the x, y, z's. So in this one, we have k, and we have k squared. You need to include the efficient when you discuss variables. Next, our coefficients. Coefficients are the numbers that are multiplied onto the variable. So the number that is directly stuck on front of any variable. Here we have -3 and -7. Okay. One more piece of information is our constant. It's the poor thing that is constantly alone. Let's try another one. Let's go backwards. First thing we're looking for, I'm going to change that. Okay. The first thing we're looking for is going to be our constants. The constant is the one that is constantly alone. So there we are, we have our 3. The coefficients. Now this is a little tricky. It looks like we don't have any numbers being multiplied onto the m or the n. We know that when there is no number in front of your m or n, that it actually means that we have one m and we have one n. So in this particular case, our coefficients are -1 and -1. Now our variables. Our variables are the alphabet letters. We have a variable called m, and we have a variable of n cubed. You have to include your exponent. And finally, what is our degree? Well, the m has a degree of simply 1. The n has a degree of 3. 3 beats out the 1, so our degree is 3. Now we're going to look at how polynomials and algebra are blended together. This has been happening in your curriculum before this year, we just haven't labeled it as polynomials. When you see a word problem like this, we're going to first begin to put it into a polynomial so that in our next unit, when we're looking at algebra, we can solve the problem. So we have poor little Sally planning her birthday party. She plans on inviting 12 different friends. The cake is going to cost her $35. The loot bags are going to be $4 for each. Represent this problem as a polynomial. So we're going to start with the cost that doesn't change. If she has one person show up, she still needs the cake. If all 12 show up, she still needs her cake. So that $35 is going to be our constant. It does not change. Then we're going to add the loot bags. We know that the loot bags are $4 a piece, but yet we don't know how many people are coming. So 4 times question mark? Well, we're a little more sophisticated than that now in grade 9. Instead of leaving it as question mark, 4, and we're going to give it a variable. Let's call that 4x. So the birthday party would be represented by the constant birthday cake, $35, plus $4 per person. You're going to go ahead into your textbook on Chapter 6, Section 6.1, which is on pages 281 and 282, and you're going to complete questions 1 through 5 and 7 through 15. These are due next class.